This is my pre-algebra course. Today we're going to continue to learn applications of algebra, but today we're going to learn how algebra is used to solve equations. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by using applications of one-step equations. If the area of a rectangle is 30 square centimeters, and the length is 5 centimeters, what is the width? Now, whenever you do these problems where you're applying algebraic equations, I always want you to write the equation first, just like in the last class. So if you get out your equations, we know that A is equal to L times W. So what we're going to do, again, you have to write this formula first. And what we're going to do is we're going to rewrite this formula down here. We're going to bring the equal sign straight down as usual, and we're just going to keep bringing it straight down. And we're going to rewrite this exact formula, except we're just going to plug in the numbers we know, and then we're going to solve for the numbers we don't know. So we know what A is. We know that A is 30. So instead of A down here, we're going to write 30. And we know that L is 5. They tell us the length is 5. So instead of L, we're going to plug in 5. But we don't know what W is, so we're just going to keep that W. And now you can see this is a one-step algebraic equation. So we have to perform one operation on both sides of the equation. So whenever we perform an operation on both sides of the equation, we have to rewrite the equation, and then we can perform our operation. And then we write the result. The 5's cancel out, and 30 divided by 5 is 6. So the answer is 6 centimeters. If the height and area of a parallelogram are 20 feet and 10 square feet, what is the base? So get out your formula, and you should have that list of those formulas that we did in the last class, and you can find all the math formulas you want online also. The area of a parallelogram is equal to the base of the parallelogram times the height. So you write your formula, and then just like in the previous problem, you're going to plug in what you know and solve for what you don't know. So we know that the area is 10 square feet because they tell us that. And we know that they give us the height this time, so we're going to write the height over here. And then it's not traditional to write the number on the right side. So I'm just going to go ahead and put parentheses around that so there's no confusion. So now we're about to perform an operation on both sides of the equation, so we have to rewrite the equation. And then we perform the operation. And 10 divided by 20. So this is going to be a fraction. So we can just reduce that fraction. Divide both sides by 10. 10 divided by 10 is 1. And 20 divided by 10 is 2. So the answer is 1/2. And we need to write, instead of rewriting it, I'm just going to go ahead and write the units here. So you need to write your units. So that's 1/2 feet. All right, so now it's time for you to try. I'm going to keep these problems up there so you can see. So go ahead and try number 3. And when you come back, we'll do it together. All right, we're back. So this is the same type of problem. You're going to write your area formula for a rectangle. And they tell us that the area is 40.5 and the length is 9. So now we have a one-step algebraic equation. We're about to form an operation on both sides of the equation. So we rewrite the equation, and that's 9 times W. A number next to a letter is multiplication, remember. So you have to do the opposite of multiplication, which is division, and we show division with the fraction sign. So W is equal to 40.5 divided by 9. Now I forgot to mention that whenever you have decimals in this class, or pretty much any decimals in the classes in the course, my pre-algebra course, you can just use a calculator. So 40.5 divided by 9 is 4.5. So the answer is 4.5. If you got 4.5, good job. But remember, you have to write your units. It's meters. So the width is 4.5 meters. Try number 4, and when you come back, we'll do it together. All right, we're back. So, again, you got to write your formula. You have to write that formula. You have to show the tool that you're using. So they tell us that the area is 0.8, and the width, they tell us, is 1.8. So we're about to perform an operation on both sides of the equation, so we have to rewrite. And now we're ready to perform the operation on both sides. And we can get out our calculator now. Again, you don't have to do that. You can do the arithmetic. We learned how to do the arithmetic in the previous class, or previous course, but you don't have to. All right, so we end up with 0.4 bar. And we need to move that over so we can write inches. So if you got 0.4 bar inches, good job. But remember, you have to write that unit. You have to write IN for inches. All right, so I want you to understand that sometimes you're not going to get a word problem when it comes to these types of problems. Sometimes you'll just have a picture. The picture will be given to you, and you'll be given the knowns. The knowns are 1.3 and 20, and you'll be asked to find the unknown, which is W. So this is pretty much the same type of problem. Go ahead and try number 5. And remember, you can use a calculator because we're using decimals. So try number 5, and when you come back, we'll do it together. All right, we're back. So again, you must write the tool that you're using, the formula. Plug in what you know and solve for what you don't know. And you have to show every single step. Don't think that you can get away with not showing what you're doing. You can't. All right, 1.3 divided by 20 equals 0.065. So W equals 0.065, and I haven't left enough room for myself as usual there. Oh, wait a second, there is no unit. I should have mentioned this. I didn't mention it. In this problem, you were not given units. So if you're not given units, you can just write the number. There's really no unit to write. So if you got 0.065, good job. All right, so area of a parallelogram is base times height. So go ahead and try number 6. Remember, you got to write that. You got to write the tool that you're using. A equals BH. You got to write that. And when you come back, we'll do this together. All right, we're back. So the area is 36. The base is 4. And we got to rewrite. Divide both sides by 4. And we have h is equal to 9 feet. So if you got 9 feet, good job. All right, so now we're going to do a distance, rate, time problem. So this is not one of the formulas that you have on your sheet that we did last time in the last class. So I'm going to give you the formula right now. The rate is equal to the distance divided by the time. So for example, miles per hour is a rate. So in order to find the rate, you take the number of miles and you divide it by the number of hours, and that tells you how fast something is moving. So in this problem, we're given the rate and the time, and we're asked to find the distance. So that's what we're going to do. So I have my tool here. I wrote my tool. I know what tool I'm using. So I'm going to plug in what I know. I know R, and I don't know D, so I'm just going to write D, but T I know is 7. So now I just have to solve this one-step equation. So I'm going to perform an operation on both sides, so I have to rewrite the equation. And D is divided by 7, because remember, the fraction line means division. The fraction line means that you're dividing by 7. So in order to get rid of the 7, I have to do the opposite of dividing by 7. I have to multiply by 7, and to show multiplication, we use parentheses. So the 7's cancel out, and I'm left with D is equal to 28 miles. So again, this is the formula that you need to write down or remember for these problems. So I want you now to try problem number 8, and when you come back, we'll do it together. All right, we're back. So you should have written your tool. The tool that we're using is R equals D over T. We know R is 8.4, so we plug that in for R. We don't know D, but we know that T is 3. Now we're going to solve that equation. We have to multiply both sides by 3. We show multiplication with parentheses. And you can get your calculator now, because this is a calculator problem. 3 times 8.4. 3 times 8.4 is 25.2. And as usual, I wrote that too close to the equal sign. I got to move that over. And what is the unit? Unit for distance is going to be meters. And how did I know it was meters? Because the rate was in meters per second, so it's got to be meters. I knew this was miles because it was miles per hour. All right, so sometimes you're going to see a word problem version of this. So why don't you go and try number 9, and when you come back, we'll do it together. All right, we're back. So write the formula that you're going to use, the tool that you're going to use. We know the rate is 64, and we know the time is 5. So that's a one-step algebraic equation. We're going to have to rewrite the equation because we're going to perform an operation on both sides. We show multiplication with parentheses. And D is equal to 320 miles. So if you got 320 miles, good job. You're on the right track. All right, so on to number 10. These problems are going to be percent problems. In the last course, my arithmetic course, we learned how to find the percent of a number. So in order to do these problems, we're going to have to review how to find the percent of a number. So we want to find 79% of 21 as an example here. Now finding the percent of a number is really easy. All you do is you take the percent and change it to a decimal, and then you multiply it into the number. So whatever this number ends up being, that number is 79% of 21. Now, in case you forgot how to change a percent to a decimal, what you do is you find the decimal in the percent. Whoops, I accidentally erased that. You find the decimal in the percent, and you move the decimal to the left two times, or two places. So if the percent is 79%, you take wherever the decimal is and move it to the left. But the problem is we don't know where the decimal is. Where's the decimal? It's invisible. Well, remember in my previous course we learned that whenever you don't see a decimal, it's always directly to the right of the number in the ones place, which is 9. Because 79 is a whole number, so the decimal is always there. It's invisible, but it's there. So you move it over 1, 2 places, and that's where we got 0.79. Now, in the problem on example 2, the decimal is here, so it's not invisible. So in that case, you would move it over. It's 8.2, so you would take the decimal, move it over 2 places, and it would be 1, 2, and it would become 0.082. So that's how you change a percent to a decimal. So you multiply 0.79 times 21, 0.79 times 21, and you get 16.59. That makes sense because 79% should be less than 21 because we're only finding a percent of 21. So why don't you try example 2, and when you come back, we'll do it together. All right, we're back. So we're going to change the percent to a decimal, and then we're going to multiply it by 56. 0.082, I got my calculator here, times 56 is equal to 4.592. So if you got 4.592, good job. Now notice that I'm writing crosses here. You're probably saying, well, wait a second, I thought you said we're not going to use crosses. Well, 99% of the time we're not going to use crosses, but we do use crosses sometimes. I don't have to use crosses. I could use parentheses, but in this case it's traditional to just go ahead and use parentheses there. Or excuse me, use crosses. It really doesn't matter. You can use parentheses if you want. In fact, in problem number 3, when I demonstrate, I'll use parentheses. But why don't you try example 3 first, and when you come back, we'll do it together. All right, we're back. So change the percent to a decimal. And again, the decimal is here, so we go 1, 2 places to the left. And then you multiply that into the number. And 2.33 times 19 I'm doing on my calculator, and we get 44.27. And I have to rectangle these. So that's the basic concept of finding the percent of a number. So notice that we haven't done any algebra yet. We're just reviewing that concept from the last course. So now we're ready to do some algebra. We're going to do similar problems, but the unknowns are going to be one of these numbers. So these problems are going to be slightly different because we're going to start to use algebra. We didn't need any algebra for these problems that we just did, but we're going to use algebra for the next problems. So let me demonstrate. If 23% of a number is 12.88, what is the number? So remember, in order to find the percent of a number, you take the percent and you change it to a decimal. Then you multiply that into the number. But in this case, we don't know what the number is, so we can just write x. And that equals 12.88. So you can see this is a one-step algebraic equation. So, and you can use x or you can use n. Some people like to use n. It might be familiar to you to use n. I'm just going to use x because we've always used x, y's, and z's. And again, this is not multiplication. You know, I probably should have used parentheses in the... Oh yeah, I said I was going to use parentheses, but I forgot to use parentheses. So you would just write it like that if you want to use parentheses. But anyway, the x here is not multiplication. It's a letter next to a number, which means you're taking whatever this number is, the unknown, and you're multiplying it into 0.23. When a letter's next to a number, the letter represents an unknown number. It doesn't say that you're multiplying by some non-existent number here. All right, so we have to perform an operation on the equation. So we have to rewrite it. Then we have to perform that operation as we've done many, many times before in this class. And that's it. Now we just use our calculator. 12.88 divided by 0.23 is 56. So these are one-step algebraic equations because the number that we're looking for is a different number from the basic percent problem. So we're not trying to find a percent of a number. We're given a percent, and the result, we're given the percent of the number, and we're told what that percent is, and we're asked to find the original number. So number 11 is the same type of problem. So let's do one more of these together before you try one on your own. So 4.2% of what number is 0.378? So you change the percent to a decimal. And I know what you're thinking. You're thinking, wait a second, that's already a decimal. Well, it's in percent. It's an abbreviated form of a fraction. It's technically a percent. But this is not a percent, it's just a decimal. So we changed it to a decimal, and then we're going to multiply by some number that we don't know. It says what 4.2% of what number? We don't know what it is. So again, to find the percent of a number, you take the percent, change it into a decimal, and then you multiply it into the number, which we don't know, and they're telling us that that equals 0.378. That's just how you find the percent of a number. Don't overthink it. You take the percent and you multiply it into a number, and you get the percent of the number. But we're given the percent of the number. We're told the percent of the number is this number. And they're asking, what is the original number? This is an algebra problem. So we're about to perform an operation. It's a one-step equation, so we have to perform one step. We're going to perform that step on both sides of the equation. We have to rewrite it and then perform our operation. And of course, you can get your calculator out. 0.378 divided by 0.042 is equal to 9. So 4.2% of 9 is 0.378. These are one-step algebraic equations. So now why don't you try number 12, and when you come back, we'll do it together. All right, we're back. 0.83 times some number we don't know is equal to 1.494. So that's the equation. So rewrite the equation and perform your operation on both sides of the equation, just like we learned to do in previous classes. 1.494 divided by 0.83. I got my calculator out, and it looks like it's going to be 1.8. So if you got 1.8, good job. But remember, you have to show all of this work. Don't cut any corners. Don't tell yourself, well, I don't have to show the work because I don't need to show the work. Yes, you do. This course is about learning fluency and algebra, and you learn fluency by learning how to read and write the algebra. All right, so now try number 13, and when you come back, we'll do it together. All right, we're back, so you're going to change that number to a decimal. Again, the decimal is here, so 1, 2 places, and it goes right between the 1 and the 6. And I don't have to write this 0 because it's an ending 0 to the right of the decimal. And you multiply it by some number that we don't know, and the product equals 128. So now we just, it's just a one-step algebraic equation. We divide both sides by 1.6, and I got to get my calculator. Again, you could do this on paper. We learned how to do this calculation in my previous course. But it's just not, it's just going to take too much time. So if you got 80, good job. So it looks like we have a few more problems here. So go ahead and try 14, and when you come back, we'll do it together. All right, we're back. So we have to move this decimal 2 places to the left. So that means we're going to have 5 zeros in front of the 3, not including this one. So we changed it to a decimal, we multiply by some number that we don't know, and that equals 0.123400156. And so now we're going to rewrite and divide both sides. We gotta get x by itself. So we gotta get rid of that big old decimal. And I'm definitely gonna need the calculator for this. So 0.123400156 divided by 0.1234503 equals 5.2. So if you got 5.2, good job. All right, try number 15, and when you come back, we'll do it together. All right, we're back. Change the percent to a decimal, multiply it into the unknown that we don't know, or by the unknown, and the product is equal to 87.22. Rewrite, because we're about to form an operation on both sides of the equation. Perform your operation on both sides of the equation. And get your calculator out. 87.22 divided by 0.49 is equal to 178. So x is equal to 178. And it's always good to look at the answer and figure out if it makes sense. So 49% is about half. So is half of 178 roughly 87.22? Well, that does seem about right. If you get a number that's completely ridiculous, then obviously you did something wrong. So it's always good to use your common sense when you're doing these problems. Don't get lost in all the algorithms. It's very important to understand the algorithms. If you don't understand the algorithms, you can't do the problem. But if you get lost in the algorithms to the point where you're not even using common sense when you make a mistake, then people are going to laugh at you because your answer is going to be ridiculous. All right, so now we're doing the same types of problems, except now instead of finding the original number, we're going to be given the original number, and we're going to be asked to find the percent. So in the first type of problems we did, we were given the original number and we were given the percent, and we're just asked to find this number, the percent of the number. But and then the second type of problem, we were given the percent and the percent of the number and asked to find the original number. But in this problem, we are given the original number and the percent of the number, but we're asked to find what the actual percent is. I know that seems kind of complicated, but so now remember, you take your percent, you change it to a decimal, and you write your percent. But in this case, we don't know what the percent is, so we're just going to write x for the percent. Then you multiply that into the number, and I'm going to use parentheses just because it's not standard to write the number to the right like I mentioned before. And that's going to equal 7.68. So again, this is just a one-step algebraic equation. So you want to isolate x, get it by itself, so you have to get rid of that 96. And x is equal to, let me get my calculator out, 7.68 divided by 96 is equal to 0.08. Now there's one more step. There's one more step right here. Now, it's asking what percent of 96 is 7.68. When you're asked to find the percent, you have to do one extra step. Because remember, to find the percent of a number, you take the percent and change it to a decimal. You understand? You change it to a decimal, then you multiply by this number to get this number. Okay, so if you go backwards and you find the decimal, we found the decimal. This is not a percent. This is the decimal that you multiply by 96 to get 7.68. Again, this is the decimal that you multiply by 96 to get 7.68. We don't want the decimal. We want the percent. So in these problems, you have to do one extra step. You have to change the decimal into a percent. So now you're moving the decimal the other direction. Before we were changing a percent to a decimal, you move the decimal 2 places to the left. Now you want to change this decimal to a percent, and you move the decimal 2 places to the right, the opposite direction. So 1, 2, and our percent is then 8%. So that's going to be the answer. So whenever you're finding a percent, you have to do that one last extra step. All right, so 25.5 is what percent of 102? Now, you may have noticed that the wording changes. You can't get used to one particular type of syntax. Syntax is the ordering of the words, because there's different orderings. This problem said what percent of 96 is 7.68, but this problem is wording it differently. It's the same problem, but it's wording it differently. 25.5 is what percent of 102. So I'm doing that on purpose because I want you to know that there's different ways to word these problems. But the important thing is these problems are both looking for percent, which means that they're going to both be the same problem pretty much. So you set it up the same way. We're going to take 25.5 and we're going to multiply it by the percent written as a decimal. So 25.5 times the percent written as a decimal is equal to 102. Actually, no, I didn't do that correctly. I just realized I didn't do that correctly. So this goes to the different wording. What percent of 102? So this is going to be 25.5 is equal to what percent of 102? So we do 102 times the percent written as a decimal. So I almost made a mistake there. So the wording is different on this one, so you have to be careful. These equations, you got to be careful that you put the number in the right place. So what percent of 102? So you take the decimal form of the percent and you multiply it by 102, and that equals 25.5. So be careful about that. One way to avoid that problem is think of the word is as the equal sign. So if you think of the word is as the equal sign, then it doesn't make sense to do it the wrong way, the way I almost did it, by writing 25.5x is equal to 102, because that puts the equal sign in the wrong place. Is should be here, and is between the 25.5 and everything else. So that's just one way to make sure you do it correctly. All right. But as you get practice with these problems, you're going to figure out how to do it. But again, the principle is you're finding the percent of a number. What percent of 102 is 25? So you're taking the percent and multiply it by 102. You're not multiplying it by 25.5. All right, so divide both sides by 102. And x is equal to, get out the calculator, 25.5 divided by 102 is equal to 0.25. So now we have to change that decimal to a percent. So we move it 2 places to the right, And the final answer, the percent that we're looking for, is 25%. And rectangle that. All right, so now it's time for you to try. Go ahead and try number 18. And I'm going to leave number 16 and 17 in the window so you have something to refer back to. And when you come back, we'll do it together. All right, we're back. So what percent of 8? So we're going to take 8 and multiply it by a percent written as a decimal, and that's going to be equal to 0.24. So if you wrote 0.24x is equal to 8, that is not correct. That's the mistake that I almost made in number 17. You're multiplying 8 times the decimal, or the percent written as a decimal. All right, so as usual, you just rewrite because you're about to perform an operation on both sides of the equation. You divide both sides by 8. And then we get, let's see, that would be 0.24 divided by 8 is 0.03. And you have to move the decimal 2 places to the right, and our final answer is 3%. So if you got 3%, good job. If you didn't get 3%, that's okay. Just figure out what you did wrong. These percent problems can be kind of tricky. Now for 19, notice that there's a different wording. This says 60 is what percent of 54.6. When you look at the previous problem, it said it started with the word what. What percent? You see, so it's a different wording, so you really have to be careful that you set it up correctly. So remember, the is sign, you can think of that as the equal sign. So 60 needs to go over here, and the product needs to go over here. So go ahead and try 19, and when you come back, we'll do it together. All right, we're back. So 60 equals what percent of 54.6? I'm going to get my calculator out. 60 divided by 54.6 equals, and I got a really weird number there. So it looks like we're going to have to round off on that one. So I got x is equal to 1.0989. I didn't realize that was going to be a weird number. So now we move the decimal 2 places to the right, and it becomes 109.89%. All right. So that was kind of a weird problem. We rounded off to the nearest hundredth of a percent. All right, so try number 20, and when you come back, we'll do it together. All right, we're back. 29x is equal to 58.87. Again, these are all one-step algebraic equations. $58.87. I'm using my calculator. Divided by 29 is equal to 2.03. Move the decimal 2 places to the right, and you have 203%. So if you got 203%, good job. All right, try number 21. Again, we have a different wording here. You see how the wording is different from number 20? It's a different wording, so don't be confused by that. Remember, you can use the is sign as and consider that to be an equal sign. So try number 21, and when you come back, we'll do it together. All right, we're back. So I used my calculator, and I got 0.12. And so we want to know what percent, so we have to move the decimal over, and we get 12%. So we got 12%, good job. All right, so now we're going to go on to two-step equations. Those were all one-step equations. So we're going to go to two-step equations now. If the perimeter and width of a rectangle are 26 centimeters and 10 centimeters respectively, then what is the length of the rectangle? Now you're probably thinking to yourself, what does respectively mean? Why did I write that? Well, respectively means that the numbers fall in the order previously mentioned. So we said the perimeter and the width of a rectangle are 26 centimeters and 10 centimeters. So what that means is that because the, whoops, accidentally erased, because the perimeter was mentioned first, that means that because 26 centimeters is mentioned first, 26 centimeters is the perimeter. And the width was mentioned second, so 10 centimeters is mentioned second, so the width is 10 centimeters. Sorry about that, I'm just waiting for my computer to undo that. It's going slow right now. So again, respectively means that 26 centimeters, the first number is perimeter, and the second number is 10 centimeters, the width. So we have to get our perimeter formula out for the perimeter of a rectangle. So if you have those formulas in front of you, or if you just go on the internet, you can see that the perimeter of a rectangle is 2w plus 2l. And it doesn't really matter the order that you write these. You could write 2l first. It doesn't really matter. All right, so again, now notice that we put the numbers right next to the letters. There's no crosses for multiplication because this is algebra. You don't use crosses for multiplication 99% of the time. And notice also that I wrote the tool that I'm about to use. You have to write those tools that you're about to use. You have to show the reader what you're using. How do you know that this is the perimeter of a formula? Because you're using this tool. It's like if you're gonna show somebody how to build a house, you have to pull out your drill and you have to show the person the drill and say, this is the tool that we're using. All right, so we're going to plug in the information that we know and solve for the information we don't know. So this is the exact same thing that we did with one-step equations. So we know the perimeter is 26, and we know that the width is 10. So notice that because I'm multiplying these two numbers, I now have to put parentheses. When I had a number and a letter, I didn't have to put parentheses. So I could just put them right next to each other. But when I have two numbers, I have to use parentheses, or else that would look like 210. So go multiply, we need to simplify. So technically this is actually probably a three-step equation because you have to multiply the 2 and the 10 first. You have to simplify, and we get 20. So that was the first step. And we didn't have to rewrite on that step because you're just simplifying. Whenever you simplify, you don't have to rewrite. You only have to rewrite when you are about to perform an operation on both sides of the equation, and that's what I'm about to do now. So I have to rewrite. And remember, when you do two-step equations, you want to get rid of that 20 first. So the opposite of adding 20 to 2l is subtracting 20. So I'm going to subtract 20 from both sides. And we get 2l is equal to 6. So now I'm about to perform an operation on both sides of the equation again, so I have to rewrite the equation. And I can already tell I'm running out of room here, so I'm going to have to shrink that. So I rewrite the equation, and I perform the operation on both sides. And that's going to be our answer. Whatever that ends up being, that's our answer. So 6 divided by 2 is 3. So the answer is 3 centimeters. the length of the rectangle is 3 centimeters. So as you can see, it's the same thing that we did before. It's just a two-step equation. Actually, technically a three-step. All right, so we have the same situation for number 23. But now they're just showing us the rectangle and showing us what we don't know and what we do know, and you just plug in. So perimeter is equal to 2w plus 2l. We know the perimeter. We do not know w. We know l. And first step is to simplify. 2 times 15 is 30. And now we're going to perform an operation on both sides of the equation. So we have to rewrite that equation. Now I know that instinct tells us to get rid of that 2 first, but we learned in previous classes that you actually don't get rid of the 2 first. You could if you wanted to, but it would make things more difficult. So we have to first get rid of the 30. And we end up with 2w is equal to negative 30 plus 70 is 40. And then we have to rewrite that equation because we're about to perform an operation on both sides of the equation. Divide both sides by 2 because we have to isolate w. The w is not isolated because the 2 is next to it. So we have to get rid of that 2. We have to do the opposite of multiplication because when a w is next to a 2, that means multiplication. So we have to do the opposite of multiplication, which is division. We show division with a fraction sign, and w is equal to 20. 20 inches. Be sure to write your unit if the units are given. All right. So now it's time for you to try. So go ahead and try 24. When you're done, we'll attempt the problem together. All right, we're back. So again, write the formula that you're going to use. You have to show that tool that you're going to use. You have to show the reader how you know how to do the problem. You don't do the problem by magic. You do it because you have a formula that tells us what the perimeter is. So the perimeter is 34 feet and the length is 10 feet. And all we have to do on this first step is just simplify, and we get 20. And we have to perform an operation on both sides of the equation, so that means we have to rewrite the equation so we preserve the result of our first step. Subtract 20, and we get 2w is equal to 14. Now we're going to rewrite that equation because we're going to perform the third step. And we'll get out the green pen and divide both sides by 2, and you get 7. And what are the units? The units are feet, so 7 ft. That's the abbreviation for feet. So if you got 7 feet, good job. So now we have decimals, which means you can use your calculator. So try number 25. They tell us the perimeter is 3.8 and the width is 0.45. Now notice that we don't have units, so you don't have to deal with those units. So try number 25, and when you come back, we'll do it together. All right, we're back. So again, you want to write the formula that you're going to use. You have to write that formula. So P equals 2W plus 2L. And we're given the width is 0.45. And we're asked to find the length. Whoops, I forgot to plug in my perimeter. Just waiting for my computer to catch up here. perimeter is 3.8. So first step is simplify. Whoops. So we're about to form an operation on both sides of the equation, so we have to rewrite. Subtract 0.9 from both sides. And we have 2L is equal to 2.9. And we're about to perform an operation on both sides of the equation again. So we have to rewrite. I'm running out of room, so I'm going to have to shrink this. So rewrite that. And we're going to divide both sides by 2. So you can get out your calculator for this. 2.9 divided by 2 is 1.45. So L is 1.45. And again, they didn't give us any units, so we don't have to write the units. All right, so if you got 1.45 for the length, good job. So now we're going to go on to a different type of problem. Now we're going to percent change. So we learned percent change in my previous course. That's when you take a number and you increase it by a certain percent. So we're going to use algebra to solve these problems, but you only need algebra for a certain type of this problem. So the first type is very easy. For the first type, you don't need algebra. So let's go ahead and review just how percent change works. So this is the master formula for percent change. So it's best just to give an example. So let's say that 63 is increased by 72%. So the new number, which we notate as n, is going to be equal to the old number plus 72% of the old number. So that's what it means to increase a number by 72%. You take the original number and then you add 72% of that number. Now, we learned in previous problems that to find 72% of the number, you take the percent, change it to a decimal, and multiply it by the original number. So this is just a more complicated problem when it comes to finding the percent of a number. So you find 72% of the number, and then you add it to the original number, and that's what it means to increase a number by 72%. Now, if all that sounded really complicated, don't worry, because all you have to do is memorize this formula. So you can choose to understand the concept, or you can memorize the formula, whatever. Just make sure that you can do the problem. And don't complain that it's too hard. It's not too hard. Figure it out. All right? A lot of students like to complain that something's too hard, and they're really just making excuses for not wanting to do it. Just figure it out and do it correctly. No excuses. All right, so now we have to just simply perform order of operations. So you're allowed to get out your calculator. 0.72 times 63 is equal to 45.36. Because order of operations tells us to do the multiplication first. And then we do the addition. So plus 63 is 108.36. So if you increase 63 by 72%, you get 108.36. All right, so let's try a couple more of these problems. I'm going to try example 2, and you can try example 3 and example 4. Bill's score on his new video game was 170. If he increased his score by 20% the second time he played, what was his new score? So again, you can use that formula. I want you to write the formula. The new number that we're looking for is equal to the old number, the first number, plus the first number, or the percent of the first number. Now, we're doing increase. The next problem is going to be a decrease problem. So in a decrease problem, you would put a minus here. Just be aware of that. So we're going to plug in the numbers. So f is equal to, and again, this is not an algebra problem, so we're not having to write the notation in the same way that we'd write the algebra notation. Now notice that I kind of switched these numbers around. I wrote the R number first. Don't be confused by that. We're taking the original number and we're adding 20% of that original number. And by the way, I didn't mention, again, we're finding 20% of a number. So you take 20%, you change it to a decimal, and then you multiply it into the number. All right, so we take the original number and we add 20% of the original number, and we learned how to find the percent of a number in the previous problem. So let's go ahead and do that. So 0.2 times 170, we use order of operations, so we have to multiply first. So we get 34, and then we add those up, and we get 204. So that was Bill's score the second time. He went from 170 to 204. All right. So now it's time for you to try. But remember, when you write this formula, first write your formula, and it's going to be a decrease. Arnold's weight decreased by 5%, so it's going to be F minus F times R. So go ahead and try number 3. When you come back, we'll do it together. All right, we're back. So the first number is 185 pounds. And then we're going to subtract 5% of 185 pounds. So 0.05 times 185 is equal to 9.25. And 185 minus 9.25 is equal to 175.75. But in this problem, you need to write the units because we're given units. In the previous problem, we were just given a score. There's no units for a score generally in a video game. And in the first problem, of course, we were not given units either. So anyway, if you got 175.75 pounds, good job. So again, we're not doing any algebra right now. The only purpose of this is to review the concept of percent increase. So why don't you try one more of these to get the hang of it, and then we'll actually apply this to algebra. So try example 4, and when you come back, we'll do it together. All right, we're back. The new number equals, we're doing decrease again, so it's going to be minus. So the first number was 11,123, but it was decreased by 71%. So we find 71% of the original number. So 11,123 times 0.71. And we get, now we're going to have to put dollars here, 3,225.67. So she spent quite a bit of money. It looks like she spent about $7,000 or $8,000 on that motorcycle. That's typically what motorcycles cost if you buy an affordable one. But they can go all the way up to $20,000 or even $50,000 if you buy a really nice one. All right, so if you got that answer, good job. So now we've reviewed percent change. So now we're going to apply this to algebra. if a number is decreased from 75 to 66, what is the percent decrease? So this is talking about percent decrease, that's percent change. So we have to write the formula that we're going to use, and it's decrease, so it's going to be minus. And now, just like we did the other problems, you're going to plug in what you know and solve for what you don't know. And the reason that this is going to be an algebra problem is because we're looking for one of these unknowns. If you're looking for n as the unknown, then there's no algebra that's required if you're looking for n. But if you're looking for the other numbers, then it becomes an algebra problem. So the problems we did previously, we were looking for n. There was no algebra involved. But in these problems, there's algebra. So n, we already know, n is 66. That's the new number. It decreased to 66. And the first number we know was 75. But we don't know what the percent decrease was. So we're looking for r. So as you can see, this is a two-step algebraic equation. So we're going to rewrite the equation, and we're going to subtract 75 from both sides. And that would be -9, I believe. And then we can get out our calculator, 0.12. But again, we want percent, so we have to change that to percent, and that's our final answer. So the number decreased by 12%. All right, let's try another one of these together. So I'm going to put a divider here. So again, we write our master equation, the equation that we're using. And this is an increase, so we have to put plus for increase. Again, if it's an increase, you put plus. If it's a decrease, you put minus. So again, they give us n and they give us f, and we have to find r. So the new number is 56. That's the number it changes to, and the original number, the first number, is 20. And that just becomes an algebraic equation. Remember, you have to rewrite every single time you perform an operation on both sides of the equation. You're not going to have to do that in classes after this class, or courses after this one, but in this course you have to do it because you're learning the language of algebra. You don't know the language of algebra completely yet, so you have to learn it in this class. And we get 1.8, and I'm just going to do a line over here. We have to change that to a percent, so it becomes 180%. If you move the decimal 2 places to the right. All right. And that makes sense because you're going from 20 to 56. That's a big increase, so it's a 180% increase. So here's a real problem, a problem applied for the real world. But you can go ahead and try this one on your own. And when you come back, we'll do it together. All right, we're back. So again, you're going to write your master formula. And this is a decrease because it was reduced in volume. The new number is 0.1 ounces. The old number is 0.5 ounces. And we don't know what R is. We don't know what the percent increase is, or the percent decrease. remember, you have to divide by that negative also. The negative goes with it because you want to isolate r. You want to get r by itself. But in order to get r by itself, you have to get rid of the 0.5 and the negative because they go together. All right, so I get 0.8 is equal to r because a negative divided by a negative is always a positive. Move the decimal 2 places over and you get 80%. It's an 80% decrease in volume of the cookies. So if you got 80%, good job. All right, on to number 29. Why don't you try number 29? And when you come back, we'll do it together. All right, we're back. And this is an increase. 6 is the new number because that's what the number is becoming. All right, so we're going to rewrite that. And we're going to get what looks to be a repeating decimal. So r is equal to 0.09 bar. And I'm going to put a little arrow up here. So the percent is going to be 0.09090909. It just keeps going on and on and on. Whoops, I kind of messed up one of those zeros there. My computer's going real slow here. Sorry about that. All right, so we just move the decimal 2 places over, and you end up with 9.09, and the 09s are barred because they still go on forever. So sorry I gave you a decimal there. Repeating decimal. All right, so try number 30, and when you come back, we'll do it together. All right, we're back. All right, 50 divided by 80 is 0.625. Move the decimal 2 places over and you get 62.5%. So if you got 62.5%, good job. Try number 31, and when you come back, we'll do it together. All right, we're back. Write your master formula with subtraction because it's a decrease. All right, and 2 divided by 5 is 0.4. Move the decimal 2 places over and you get 40%. So if you got 40%, good job. All right, so let's try another one of these problems, but this is going to be different, because in this problem we're looking for something different. So let's write the master formula. This problem is different because in this problem, they're giving us the new number, but they're not giving us the first number. They're not giving us these f's. F is the number that we're actually looking for in this problem. In this problem, they give us R. So let's write the original number. Let's write the new number is 30. And the original number we don't know, but we do know R is 0.96. And again, I'm writing the number to the right of the letter, so I'm just going to put it in parentheses so there's no confusion. Again, when you write the number to the left of the letter, that looks normal, but when you write the number to the right of the letter, it looks kind of weird. So I'm just going to use parentheses for that. All right, so then I'm going to modify that so it looks more normal. So I'm going to put the 0.96 on the left side of F. So now at this point, we can actually go ahead and just combine these f's, because remember here, if you don't have a coefficient in front of the f, that just means one f. It's like putting a 1 right there, 1f, right? So you have 1f and you're going to subtract 0.96f. So that's 1 minus 0.96. So go ahead and do that in your calculator. 1 minus 0.96 is equal to 0.04. So all we did was we just combined terms. Remember in the previous classes where we would have like 2x minus 3.5x, you know, stuff like that. And these are like terms. You can combine those. Now you cannot combine 5 plus 3x because one term has an x and the other term doesn't. You can't combine those. But since both of these terms have f's on them, both of these terms here have f's, we can combine those. Those are called like terms. It's like saying 2 apples plus 3 apples is 5 apples. Or 8 apples minus 5 apples is 3 apples. But you can't say 8 apples minus 5 lemons is 3 apples. That doesn't make any sense. So you have to have like terms. So now, of course, we can just rewrite because we're going to perform an operation on both sides of the equation. Please understand that from this point all the way down to here, we didn't perform an operation on both sides of the equation. What we did here, from here to here, is we just simplified. We just simplified the equation. So whenever you simplify something, you don't have to rewrite the equation because you're not performing an operation on both sides of the equation. But now we're performing an operation on both sides of the equation. All right, so 30 divided by 0.04 is equal to 750. So that is the answer. So this is kind of the same type of problem we were doing, except there's just a different unknown. If the average length of a lizard is increased by 4% and the new average length is 5.408 centimeters, what was the original length? So this is an increase, so we're adding. The new number is 5.408, and the original number we don't know, so we're just going to write f. But we do know that r is 0.04, because, again, you have to take the percent. Now, I don't know if I mentioned that, but you have to take that percent and you have to change it to a decimal. You always have to change it to a decimal when you're putting the percent into an equation. So I'm just going to rewrite that so that the number is on the left side so it looks more normal. And then of course we're just going to simplify the right side of the equation. 1f plus 0.04f is 1.04f. I can just do that in my head because that's a pretty simple calculation. All right, so now at this point we're going to perform an operation on both sides of the equation. And keep in mind that this is different. The way that we solve this equation is slightly different from the way that we solve the previous types of equations. On the previous type of equation, we were given f. We were given f and we were given n. So we solved that a little bit differently. So you have to know how to solve the different types of equations, the different forms of this problem. So now we have 5.408 divided by 1.04, and we get 5.2. So the original number is 5.2. And it's always good to go to that number and see if it actually makes sense. If it's increasing 4%, that's not a very big increase. So if you go 5.2 to 5.4, that's not a huge increase. So it makes sense that that answer would be correct. Now, there's one thing that I forgot. Do you see what I forgot? If I were taking a test, I would get 1 point taken off. I forgot to write the units for the lizard's length. The units are centimeters. So be sure to write those units if you're given units for this problem. All right, so now it's time for you to try. Again, on these problems, you're going to be looking for f. So write that master formula and go ahead and attempt 34, and when you come back, we'll do it together. All right, we're back. It's an increase, so it's plus. And the first number we don't know. And I don't really have to reorder these problems. I just did that for my own sake. I don't have to reorder the terms. So that's just going to be 1.06f. If you add those, 1f plus 0.06f is 1.06f. So now we're at the step where we're actually going to perform an operation on both sides of the equation. And now we can get out our calculator. Again, in my previous class, you were not allowed to use a calculator. You actually had to do the calculation on paper. But now you can just use a calculator, and we end up with 24. So the original number, the first number, that's why I come up with the f. First number is 24. I can't say original number because that I'd have to use an O, and that would look like a 0. So if you got 24, good job. So why don't you go ahead and try 35, and when you come back, we'll do it together. All right, we're back. So write your master formula. You always have to write the tool that you're using. The elephant grew to 770 pounds, and the percent increase was 250, so if you change that to a decimal, it would be 2.5. So 1f plus 2.5f is 3.5f. And again, this is a two-step algebraic equation. All right, 770 divided by 3.5 is equal to 220. So the elephant was 220 pounds when it was first born, and I have to move that number over because I have to write pounds. That's correct. That's about what elephants weigh when they're born, about 220 pounds. All right, so if you got 220 pounds, good job. So on to number 36. Go ahead and try 36, and when you come back, we'll do it together. All right, we're back. 0.0249 divided by 0.83 is equal to 0.03. So the original number was 0.03. So if you got 0.03, good job. All right, so try 37, and when you come back, we'll do it together. All right, we're back. All right, let me get my calculator out. And we get F is equal to 36, and it's dollars, so we got to put $36. So if you got $36, good job. All right, so now we're going to go to applications of three-step equations. So we actually did one equation that was actually technically a three-step. But for the three-step equations, we have simple interest, or simple interest formulas. Stacy deposits $400 in a bank account which earns simple interest paid annually. After 4 years, she has $411.20 in the account. What was the interest rate of the account? So if you recall, the amount of money in a bank account is equal to the original amount, principal, plus the principal times the interest rate times the amount of time that it's in the account. So that's our master formula. That's the formula that we're going to be using for these interest problems, these financial problems. So this is only simple interest. We have not learned compound interest. That's beyond the scope of this course. So we're going to plug in the number. It says after a certain amount of time she had $411.20. That's the number. That's A. That's the number that she has after a certain amount of time. The number she had originally was $400. So you put money in an account, a savings account, and it grows. The amount grows because the bank invests the money, and they pay you. They give you some of the profits from their investments. That's how the savings accounts work. And then we're going to multiply by R. It says, actually that's what we're looking for. We don't know what R is. But it says it was in the account for 4 years, and it says that the simple interest is paid annually. So see the annual here? That means it's paid every year. So that just means that our time, our unit time is going to be years. All right, so so we're multiplying all of these together. So that's the first step, is to simplify, and let's go ahead and do that. So 400 times 4 is 1,600. So now, that was the first step. And now we just have a two-step equation. So the first step is we simplified. We didn't have to rewrite because we weren't performing an operation on both sides of the equation, but now we're going to have to rewrite. We rewrote already, and I'm going to perform an operation on both sides of the equation. And I'm going to have to move this over because I'm already, well, I guess that's about as much room as I have there. And I have $11.20 over here. And now we have to get out our calculator. So 11.2 divided by 1,600, or 1,600, is equal to 0.007. Whoops, I forgot to show that step there. you have to rewrite, show the operation that you're performing. And I already did the calculation. R is equal to 0.007, but they want a percent. So you can't just leave it like that. You have to change it to a percent, so it's going to be 0.7%. Remember, you move that decimal 2 places to the right. Now I know what you're thinking. You're thinking 0.7%. That doesn't seem like a lot. Well, savings accounts really don't pay a lot. They don't give you a lot of money for their investments. It's just a little bit. All right. So in this next problem, they're asking us for the amount of time. So the unknown is t. In the previous problem, the unknown was r. In this problem, the unknown is going to be t. So let's do it together. You're going to write your master formula, and you can find this formula in my previous class, but you can find it on the internet too if you forget what it is. So we have $113.60 is the amount that it grows to. We have 80, which is the original amount that was put in the account, and we have a 0.06 decimal there. Change the percent. Yep. Notice that I changed the percent to a decimal. I took 6% and changed it to 0.06. You cannot use a percent in an equation unless you change the percent to a decimal first. All right, so first step is to simplify, and I can just get rid of that ending 0 on the 113.6. And so now, get your calculator out. 80 times 0.06 is 4.8. So all I did was just multiply those two numbers. And now I'm going to perform an operation on both sides of the equation, just like we did before. So minus 80, and I've got very little room here. Minus 80. So you're left with 4.8t is equal to 33.6, it looks like. And we have to perform another step on both sides of the equation, so rewrite that equation. Again, whenever you perform an operation on both sides of the equation, you have to rewrite that equation so you can preserve the result of your previous step. So now we do 33.6 divided by 4.8, and we get 7. So it looks like the it was in there for and it says years. It says simple interest every year, so that would be 7 years. You have to put your units there. All right. So now it's time for you to try. Try number 40, and when you come back, we'll do it together. Remember, your formula is A is equal to P plus PRT. I'm going to go ahead and write that formula in case you forgot. So A is equal to P plus PRT. Go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. A is 7071.68. P is 2009. And R, 7% interest rate, so it's going to be, you have to change that to a decimal, and it's going to be 0.07. And the time we don't know, so that's what we're looking for. How much time has passed? So we're going to simplify, that's the first step. So we multiply those numbers, and then we can rewrite and perform an operation on both sides of the equation. As you can see, it's kind of running out of room here. And we're going to need a calculator for this. 7071.68 0.68 minus 2009 equals, now we're going to perform another operation on both sides of the equation, so we have to rewrite the equation as usual. And now we're ready to divide both sides. And of course you can get your calculator out now. And we get 36. And it's daily. It says daily, so that means that the time is going to be 36 days. You have to put days there. Alright, so let me shrink this because we're running out of room here. So now why don't you go ahead and try 41, and when you come back we'll do it together. Alright, we're back. So write your master formula. I'm going to move this over a little bit. I'm going to simplify. 0.023 times 600 is 13.8. Perform an operation on both sides, subtract 600. So we get 331.2 on the left side. As usual, rewrite. And we have, let's see here, divide both sides by 13.8. And t, 331.2 divided by 13.8 is 24 months, because our unit is months. So if you got 24 months, good job. Alright, so on to number 42. Now we're doing applications of equations requiring 4 or more steps. So if you've gotten this far, good job, I'm proud of you. So now we're using this crazy physics equation. This is from physics class. Now you don't have to know physics in this course. This is just an example of a physics equation. Now please understand that these subscript zeros they're not actually zeros. That's just part of the notation. X0 is one number, V0 is one number, but that's technically not pronounced X0 and V0. They're actually X0 and Z and V0. So this is the initial position, and this is the final position. So if it says not, that means it's initial. That means initial. So this is initial position and initial velocity. That's just what that means in physics. So don't be confused by that. All right. So I know this looks really complicated, but you know it's not complicated at all. So please don't be intimidated by that formula. So all we're doing here is they're just giving you information. They're giving you things that we know, and then you have to use the equation to solve for what we don't know. That's all that's going on here. It's very easy. Okay, so we're going to use that formula. You're going to write the formula that you're going to use. All right, and then we're going to plug in what we know. We know x is 31. We know x0 is 20. We do not know v0, but we know that t is 1. We know that a is -2. And again, t is 1. So all I did was just plug in the numbers that we knew and just left the number that we didn't know. So now we have 20 plus v0 times 1 is just v0. Anything times 1 is just itself. And then I'm going to simplify all this stuff very quickly in my head here, because it's just going to take a while. We're running out of time in this class, so I'm going to do this. So you have to follow the order of operations. So you have to do the numerator first. So in the numerator we have exponents, so 1 to the second power, that's just 1 times 1 is 1. And then 1 times -2 is -2. And -2 divided by 2 is -1. So we're left with -1. So I know that I did a lot there all at once, but you know, if you're going to have some sort of a problem, that's probably going to be where the problem lies. Again, I'm sorry I did that quickly, but we're just running out of time here. Just follow the order of operations. That's just like you did in the courses on how to evaluate algebraic expressions. So now we're going to combine the 20 and the 1. 20 plus -1 is 19. So notice that we haven't performed an operation on both sides of the equation yet. All we've done is just plug numbers. So now we're going to perform an operation on both sides of the equation. So we subtract 19 from both sides of the equation. And, you know, I'm just realizing that this is not, I mean, technically we did all these steps here, so that was multiple steps, but I'm actually condensing this into a three-step equation. So V naught is equal to 12. And that's it. That's that problem. So, all right. Let's go on to the next one here. Again, you're going to write your master formula. Now, a lot of you are probably saying, well, I don't want to write that formula because I already have it up there. Well, so what? You have to rewrite the formula to show which tool you're using. V naught is 2. We know V naught this time. So we plug in V naught. But in this problem, we don't know what A is. T is 3. And so in this problem, we're looking for A. So now let's simplify. So 10 plus 2 times 3 is 6. Order of operations tells us to do the multiplication there. And then we have to simplify the numerator. So 3 to the second power is 9. So we end up with 9A over 2. So now at this point, 10 plus 6 is 16. And now we have an equation where we have to perform operations on both sides. So we're going to subtract 16 from both sides. And we get -31 on this side, it looks like. And we have to perform another operation on both sides. So we rewrite, and we're going to get rid of that 2 by multiplying both sides by 2, and you have to put -31 in parentheses also so it doesn't look like subtraction. And you end up with 9A is equal to -62. Now we have to rewrite again. And get out the purple color, divide both sides by 9, and we're out of room, so that means we just take an arrow, and we have A is equal to, and you can use the calculator for this, 62 divided by 9 is equal to 6.8 bar, and it's going to be -6.8 bar. All right, so I don't think we have time to do 44 and 45. That's just the same type of problem, so hopefully you have enough to get that problem done. We might come back to that if we have time, but I'm going to go forward here because we need to get these other problems done. All right, the sum of 3 consecutive even integers is 252. Identify these integers. So this is a problem requiring more than 3 steps, or more than 4 steps. So here's how you do this problem. You add up 3 consecutive even integers and you get 252. Now, first of all, integers are just whole numbers. We learned that in the last course. So that just means they're going to be whole numbers, no fractions, no decimals. And even means the number has to be divisible by 2. So the numbers are going to be 0, 2, 4, 6, 8, 10. Those are even numbers. Odd numbers would be 1, 5, 7, 9, 11, 13, 15, so on and so forth. Now the big question you're probably asking is, what does consecutive mean? Well, consecutive just means right next to each other. So for example, even numbers that are consecutive would be like 52, 54, 56. These are next to each other. So we're told that there are 3 consecutive even integers, and we're going to add those up and get 252. So here's how we do this problem. We have to identify what these integers are. So you add 3 consecutive even integers and you get 252. What are the integers? So the first integer we're going to call, the smallest integer we're going to call x. We don't know what it is. Okay, that's the important thing. We don't know, so we have to call it x. Remember, that's what algebra is all about. You take a number we don't know and you call it x. So let's say let's just pretend that the number is 50. Okay, pretend. So now the next number, that's going to be, if the next number is obviously going to be 52, right? That means that you have to take this first number and add 2 to get to the next even number. All right? So then to get to the next number, you add 2 again, and you just keep adding 2 to get more and more consecutive numbers. So again, if the number is 50, then you add 2 to get 52, then you add another 2 to get 54, and so on and so forth. So if the first number is x, then the second number is going to be x plus 2. You just add 2. Now, I know that seems really, really difficult, but it's not. You know, don't make it out to be something that's harder than it really has to be. So now the next number, you're just going to add 2 to the previous number. But we know from previous classes, if you just add 2 to x plus 2, you get x plus 4. Again, there's no mystery behind that. It's simple. Don't overthink this. It's very, very simple. All right, so now we can develop an algebraic expression that is going to help us solve this problem. So now we know the problem tells us that if we add up those numbers, x plus 2 plus x plus 4, that sum has to equal 252. That's what this problem is telling us. Now, notice that I put parentheses on the x plus 2 and the x plus 4. The only reason I did that was to show you that those are individual terms. You actually don't need those parentheses. You see how the pluses are connecting the parentheses? When pluses connect, when pluses connect parentheses, you can just get rid of the parentheses. You don't need them. So we're going to go ahead and get rid of those parentheses. And so now we're going to solve the equation. So this is a very easy equation. Now, it's important to understand that when you see an x by itself and there's no coefficient in front of it, that just means there's one x. So that's like if you were to put a 1 in front of all these x's. They're just 1 x's. So what we're going to do is we're going to simplify. That's the first step. So add up all those x's and you get 3x. Add the 2 and the 4 and you get 6. So now we have a two-step equation. So now it's right back to what we were doing before. So we're going to perform an operation on both sides of the equation. So we have to rewrite the equation. And we're going to get rid of the 6 first. So 252 minus 6 is 246. So we're going to have to rewrite that equation again, or rewrite again, perform our second operation. And 246 divided by 3 is 82. So 82 is the smallest of those integers. Now in this problem, they want us to find all of the integers. So if that's the smallest integer, the next integer would obviously be 84, and the next integer will be 86. And that's the answer. So as you can see, that was a problem that required many, many steps. And if you learn how to do these problems, it's going to give you a lot of confidence. All right, so the sum of 4 consecutive odd integers. So again, the first number is x. The second number is going to be x plus 2, and it's the same with odd integers. It's the same type of problem. If you have like 49 would be odd. 49 would be an odd number. Then the next one you would add 2 to get 51, the next odd number. And then 53 would be the next odd number, and so on and so forth. But now we have 4, so we have to go all the way to x plus 6. So it says the sum of all those numbers is equal to 152. So we have to add up all those numbers. And that equals 152. So again, the only reason I'm putting the parentheses there is to show us that those are individual terms conceptually. So now we can just add them all up, add all the x's to 4x. 2 plus 4 plus 6 is 12. Rewrite the equation. And we're ready to perform an operation on both sides of the equation. So subtract 12 from both sides. And we get 140 equals 4x. We have to perform an operation on both sides of the equation, so we have to rewrite. And 140 divided by 4. Let me get my calculator out for that. 140 divided by 4 is equal to 35. So x is equal to 35. That's the smallest integer. All right. So the integers will be 35, 37, 39, and 41. Remember, there are 4 of them in this problem. In the previous problem, they were only saying that the sum of 3 numbers, 4 in this one. All right, so now we have 2 more problems, and then we'll be done with the class today. So why don't you try number 48, and when you come back, we'll do it together. All right, we're back. So the first integer is going to be x, and the second is going to be x plus 2, and so on and so forth. Again, it's the same type of problem. So now there's only 3 of them, and we know that the sum of those 3 integers is equal to 183. So I'm going to skip a step here and just, instead of getting rid of the parentheses, I'm just going to add those x's and those regular numbers. And we're going to perform an operation on both sides of the equation, so we have to rewrite and subtract 6 from both sides of the equation. And we end up with 177 over here. And 3x, rewrite, because we're performing an operation on both sides of the equation, so we have to rewrite. Divide both sides by 3, and 177 divided by 3 is 59. So the first number is 59. So if the first number is 59, the next number has to be 61, and the next number has to be 63. So there you go. And it makes sense because those should be odd integers. All right, so why don't you try, and by the way, if you got that correct, good job. That was a challenging problem, very challenging. So very, very good. If you didn't get it right, that's okay. Just go back and figure out what you did wrong. Try number 49, and when you come back, we'll do it together. All right, we're back. So the first integer is going to be x, the smallest one. The second is going to be x plus 2. And the third is going to be x plus 4. And it's just the same problem that we were doing before. So now if we add up all these numbers, they tell us in the problem that the sum is going to be equal to 308. So add all those x's up, you get 4x, and add the numbers up, and you get 12. Then we have to perform an operation on both sides of the equation. Subtract 12 from both sides. And you get 4x is equal to 296, I believe. Rewrite. Divide both sides by 4. And x is equal to 296 divided by 4 is 74. So the smallest of those even integers is 74. So that means the next biggest one has to be 76, and the next biggest one has to be 78, and the next biggest one is 80. So if you got that answer, good job. So that is the class today. We didn't quite have enough time to do those last two problems, but hopefully you got what you needed to solve those problems. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or study for tests, go ahead and do that now. Let's go to the homework. So this is the homework. Take a screenshot of that. Notice you have all the answers. Here's the second two pages. Take a screenshot of that. Do all the homework completely and correctly, and check all your answers, and I'll look forward to seeing you in the next class.